Here we have problem 16.9 from homework 2. We're given a diagram of circular waves and asked to find the phase difference between points along each wave. And so the phase difference is really just a measurement of how much one wave is near or far from another one, how in or out of phase they are. And this diagram actually doesn't give us any numbers or measurements, so we can't really use our fancy mathematical equation. We're going to have to look at this kind of purely conceptually. So for part A, it's asking for the phase difference between point A and point B. Well, we can see that they're on the same second circle, so it's the same wave. They're totally in phase, no phase difference. So for part A, the answer would be 0 radians. Now for part B, it's asking for the phase difference between C and D. So here we can see it's one wave and then 2 full waves apart. So that means that we've gone through 2 wavelengths or 2 pi radians. It's just, like a circle twice. But so then that's going to give us 4 pi radians since we're going through 2 waves. And then for part C, it's asking for the difference between E and F. Well, E is about halfway between this inner circle and this outer circle, and the outer circle is where we find F. So since we're in the middle, we can say we're probably in like the middle of a wavelength, and a full wavelength goes through 2 pi. So for part C, when we're asking the difference between E and F, which would be right about here, just on the same wave, it would actually just be 1 pi radian, or half a wavelength apart. So just to reiterate, for part A, for the phase difference between A and B, that's gonna be 0 radians. There's no difference, it's on the same wave. For part B, we're looking for the phase between C and D. We said that that was 2 full wavelengths apart, so that's going to be 4 pi radians, just 2 pi times 2. And for part C, we're asking for the phase difference between E and F. And since we're going to say that's roughly, half a wavelength, 1 full wavelength is 2 pi radians, so we're just at pi